In 1981, 5 men walked into hospitals in Los Angeles with a form of pneumonia doctors almost never saw in young, healthy adults. Nobody had a name for what was killing them. Today, that same virus lives, quietly managed, in the bodies of over 39 million people worldwide, many of them taking a single pill a day, living full lives, raising families, growing old. In 4 decades, this thing went from an unnamed mystery in 5 hospital charts to one of the most studied viruses in human history. But this story does not start in a Los Angeles hospital. It starts in a rainforest, somewhere in the dense, humid canopy of southeastern Cameroon. A chimpanzee bites into another primate. Blood meets a small cut on skin, and a virus that had lived quietly in monkeys and apes for possibly millions of years takes one more step down a path that would eventually reach humans. That single moment, repeated, in different forms, dozens of times over thousands of years, is where the story of HIV actually begins. Long before it had a name, before it had a body count, before it had a single human host, this virus was just background noise. Old world monkeys across Africa carry more than 40 different strains of what scientists call Simian immunodeficiency virus, or SIV. Each one is tied to a specific species, a strain for the sooty mangabe, a strain for the African green monkey, a strain for the mandrill. And in almost all of these animals, the virus does something strange. It does nothing. These monkeys carry viral loads that would devastate a human immune system, and they walk around healthy. No AIDS, no wasting, no opportunistic infections. Scientists believe some of these virus-host relationships are so old, tens of thousands of years, possibly far longer, that monkey and virus essentially made peace with each other a long time ago. Chimpanzees hunt. They kill and eat other primates, including monkeys carrying these SIV strains. And at some point, in the forests near the Sunga, Ngoko, and Bumba rivers, a chimpanzee's immune system did something unusual. 2 different monkey viruses combined inside a single chimp, recombining into a new hybrid virus. Scientists call it SIV-CPZ. It was, genetically speaking, a mutt stitched together from the SIV of red-capped mangabes and the SIV of several Cercopithecus monkey species. And that is where everything changed, because unlike its monkey ancestors, this new hybrid virus was not so harmless in its new host. Long-term field studies of wild chimpanzees at Gom National Park in Tanzania, the same park where Jane Goodall began her research in the 1960s, found that chimps infected with SIV-CPZ had 10 to 16 times the risk of death compared to uninfected chimps. Infected females had more trouble giving birth. Their infants died more often. One infected female, followed for years by researchers, died with the same kind of immune collapse doctors would later call AIDS. In other words, the ancestor of HIV was already capable of the disease that would define its future. The world just didn't know it yet, because almost nobody was watching wild chimpanzees closely enough to notice. For thousands of years, that virus stayed exactly where it was, circulating quietly among chimpanzee communities in Central Africa, occasionally spilling into gorillas that shared the same forests, feeding in the same trees. But there was a problem. Viruses that infect one species don't automatically infect another. Every time SIV-CPZ tried to cross into a new host, it ran into a wall of human and ape biology that had spent millions of years building defenses against exactly this kind of invasion. Inside every primate cell, yours included, sit proteins whose entire job is to detect and disable foreign viruses. One of them, called tetherin, physically anchors new viral particles to the surface of an infected cell so they can't break free and spread. For SIV-CPZ to become something that could survive in a new species, it had to find a way around tetherin. And here's the strange twist. Human tetherin is slightly different from chimpanzee and gorilla tetherin, missing a small stretch of its structure, which meant the tool the virus had been using to disable tetherin in apes simply didn't work anymore once it reached a human bloodstream. The virus that eventually caused the global AIDS pandemic, the strain called HIV-1 Group M, is the only one of at least 4 separate ape-to-human crossover events that ever found a working substitute. It rewired a different viral protein, called P, to do the job instead. That single evolutionary accident may be the reason one HIV-1 lineage went on to infect tens of millions of people, while 3 closely related lineages, born from nearly identical jumps from apes to humans, infected only a few hundred people each and mostly stayed contained to Cameroon. For decades, probably 50 to 70 years, this virus spread through Central Africa almost completely unnoticed. Genetic detective work on preserved blood and tissue samples has traced the virus's most recent common ancestor to somewhere around 1910 to 1930, in the area around a city called Leopoldville, in what was then the Belgian Congo. That city is now called Kinshasa. And it is, as far as the evidence currently shows, the cradle of the entire global AIDS pandemic. Leopoldville was not a random spot on the map. Rivers connected it to the remote forests of southeastern Cameroon, where the virus first crossed from chimps into a hunter, most likely through the ordinary, brutal reality of butchering bushmeat. But the virus that infects one isolated hunter in a forest rarely becomes a pandemic. For that you need people. You need movement. You need cities. And in the early 20th century, colonial Central Africa was building exactly that. European powers had carved up the continent in the 1880s, and by the early 1900s they were extracting labor at an industrial scale. Men were pulled from villages to work river ports, railways, and plantations, a workforce that was overwhelmingly male, far from home, and living in conditions that shattered traditional social structures. Women in these new colonial cities, freed from the constraints of rural tribal life, often stayed unmarried, something that would have been almost unheard of in the villages they came from. Prostitution grew rapidly in this environment. And prostitution, combined with a population explosion of genital ulcer diseases like syphilis and chancroid, created something dangerous, a disease that increases HIV transmission risk during heterosexual sex by roughly 400 times, from under 0.1% per act to as high as 40%. This is the part that deserves real attention, because it wasn't an accident, and it wasn't hidden, it's documented in the colonial medical records themselves. Historians have combed through archived colonial health reports from Cameroon and French Equatorial Africa and found that genital ulcer disease rates in these new cities peaked in exactly the window when researchers now believe the virus was adapting to and spreading among humans, before 1935. There's also a darker, more direct thread. Colonial medical campaigns of the era administered millions of injections to treat diseases like sleeping sickness, yaws, and syphilis, frequently reusing needles and syringes without sterilizing them between patients. Some researchers argue this created repeated chains of blood-to-blood transmission, the exact mechanism a virus needs to adapt rapidly to a new host, jumping from body to body while still in its earliest, most fragile phase of human infection. Nobody can say with total certainty which of these factors mattered most: the genital ulcers, the unsterile injections, the sheer scale of new urban movement, or some combination of all three. Scientists are still arguing about it. But what nearly all of them agree on is this: colonialism didn't cause the virus to exist. It built the conditions that let a single spillover event in a remote forest become an unstoppable chain reaching millions of people. By the late 1950s, the virus had already diversified into multiple genetic subtypes circulating in Leopoldville, confirmed by testing preserved blood and lymph node samples collected from residents in 1959 and 1960. The virus was already old news to itself. It just hadn't been discovered yet. What followed was something nobody could have predicted from a single infected blood sample in a Congolese hospital. Sometime around the mid-1960s, the virus is believed to have traveled to Haiti, likely carried by a single infected person who had been in the Congo. From Haiti, evidence points to blood plasma exports. A Miami-based company was, by the early 1970s, collecting and exporting up to 6,000 liters of blood plasma a month from Port-au-Prince to the United States and Europe, at a time when nobody was testing donated blood for this virus, because nobody yet knew it existed. From there, most evidence points to New York City by around 1971, and San Francisco a few years later. By the mid to late 1970s, something was already killing people in the United States, but almost nobody recognized it as a single disease. Intravenous drug users in New York were dying of what street doctors and social workers grimly nicknamed junkie pneumonia, a condition later understood to almost certainly have been the same immune collapse that would soon get a very different name. Retrospective blood testing later found evidence of the virus's antibodies in stored serum samples from 4 drug users going back to the late 1970s. Then came June 5, 1981. The United States Centers for Disease Control published a short, almost clinical report. 5 previously healthy gay men in Los Angeles had come down with a rare pneumonia typically seen only in patients with severely damaged immune systems. Within 18 months, similar clusters were showing up in cities across the country, alongside a rare cancer called Kaposi's sarcoma. Early names for the illness reflected exactly how little anyone understood it, and how quickly it got attached to the wrong explanation: gay-related immune deficiency, or the crueler nickname, gay plague. The same syndrome was also appearing in hemophiliacs, intravenous drug users, and Haitian immigrants, which briefly earned it the clinical shorthand the 4-H disease before officials settled, in August 1982, on acquired immune deficiency syndrome, AIDS. The hunt for what was actually causing it became one of the most consequential scientific races of the 20th century, and one of its messiest. In May 1983, a team at the Pasteur Institute in Paris, led by Françoise Barré-Sinoussi and Luc Montagnier, isolated a new retrovirus from a patient's lymph node and called it LAV. A year later, a separate American team led by Robert Gallo announced they had found the cause of AIDS too, and gave it a different name, HTLV3. For a while, 2 labs on 2 continents were, essentially, describing the same virus under 2 different names, each claiming credit for the discovery. By early 1985 it became clear the viruses were identical, and it later emerged that the sample Gallo's lab had grown actually originated from the same patients studied at the Pasteur Institute. In 1986, an international committee stepped in and gave the virus the name it carries today, HIV. This is the part that still generates real controversy, more than 3 decades later. In 2008, the Nobel Prize in Physiology, or Medicine, went to Barré-Sinoussi and Montagnier for discovering HIV. Gallo was left off the prize entirely, a decision Montagnier himself publicly said surprised him, and one Gallo called a real disappointment. It's not a story of a company burying research to protect profits. It's something almost the opposite, a story of who gets remembered for a discovery that likely saved millions of lives, and who gets written out of it. By the time HIV had a name, it had already been spreading silently for 60 years. Today, the virus is not gone, it has simply changed shape. Since the pandemic strain first crossed from a chimpanzee in Cameroon, HIV has infected at least 60 million people and killed more than 25 million. It comes in 9 major genetic subtypes and more than 40 hybrid strains, each one tracing its own migration path across the planet. Subtype B dominating in the Americas and Europe after its journey through Haiti, Subtype C driving the epidemic across southern Africa and into India, a Thai outbreak in the late 1980s seeding what's now the dominant strain across Southeast Asia. Antiretroviral therapy has transformed HIV from a near-certain death sentence into a manageable chronic condition for people with access to treatment. But that access is still not universal, and the prospects for an outright cure or a fully effective vaccine remain uncertain, decades into the fight. And somewhere in the forests of southeastern Cameroon, chimpanzees are still carrying SIV. Sudi mangabes in West Africa are still carrying the virus that gave rise to HIV too. The same forests, the same hunting, the same small cuts and shared blood that started this pandemic 100 years ago are still there today. A reminder that the conditions for this kind of jump never really disappeared, they just haven't lined up the same way twice. It was there in a hunter's wound in a Cameroonian forest a century ago. It was there in the crowded river port of a colonial city learning what it meant to be a metropolis. It was there in a shipment of blood plasma crossing an ocean, and in a 5-line medical bulletin that the world almost missed. HIV crossed species. HIV crossed oceans. HIV rewrote what an entire generation understood about medicine, sex, stigma, and survival. And somewhere right now, in a lab, in a body, in a pill taken once a day by millions of people who wake up healthy because of it, it is still there, still being watched, still not entirely understood.